In this video, we're going to take a look at going from these line structures to naming alkenes. And what I would encourage you to do is actually just pause the video and see if you can't name these on your own based off of what you know so far. So go ahead and give that a try. Give this a pause, and then we'll come back to it.
A few minutes later.
All right, now hopefully you've given these a try, and then let's do a little bit of comparing and see how we do. This is a good chance to do a little bit of practice. All right, so we're going to start with this one here, and for this first one, what we're going to want to do is find out our longest carbon chain that includes the double bonds here. And it looks like we've got a number of different ways we could go. We could start here and work our way to here and go this way, or we could go that way. And it's just adding one carbon in either direction, so it doesn't really matter whether we go this way or this way. But it does matter whether we start here or here. And again, we want to end up with the smallest possible numbers. And so if we go this way, we'll end up, let's see, going 1, 2, 3, 4, 5, 6. That's one option. The other option is going in the opposite direction. I'm just going to use a green here. And let's go 1, 2, 3, 4, 5, 6, like this. All right, now if we go in this direction, going from left to right, then our double bonds are going to be at the 2 and the 4 position. So it'll be 2, 4. And then we'll end up with our substituents here at 4 and 5. If we go in this direction here with the green, well, then our double bonds are at 2 and at 4 again. And then our substituents are going to be at 2 and 3. And so that's a little bit smaller. So it seems like we ought to number going from right to left. So using the green numbers. So I'm going to go ahead and just erase the blue here, just to try to make things clear, like that. And then going from right to left, I've got 1, 2, 3, 4, 5, 6 carbon atoms, and so 6 carbon atoms should be hexane. Well, we've got 2 double bonds, becomes hexene, and because we have 2 of the double bonds, becomes hexadiene. Hexadiene. So we're going to put that in here. Hexadiene. And our double bonds are after the 2 and the 4th carbon atom, so it becomes 2-4, 2 comma 4. 2 comma 4 hexadiene, 2 comma 4 hexadiene. And then we have our substituents here. And we've got a 2 carbon atom and a 1 carbon atom over here. So this one here is a methyl, and this is ethyl. So I'm just going to label these here. Methyl, and then up here's ethyl. Okay, and we go in alphabetical order. So ethyl comes before methyl. So this becomes 3-ethyl. I'm going to go 3, if I can draw a 3. 3-ethyl. 2-methyl. 3-ethyl, 2-methyl, 2,4-hexadiene. All right. Now, if you got that one, pat yourself on the back. That's pretty good. Now, let's leave this ring structure for last. That one looks kind of tricky there. Let's go with this one here. Okay, so for this one, we want the longest carbon chain. We want to make sure we've got those double bonds in there. So let's go here. 1, 2, 3, 4, 5. And I think we want to go left to right because we're going to end up with the smallest numbers here. Notice this double bond is right off of the first carbon, whereas here, if we go in the other direction, it would be off of the second carbon. All right, so 5 becomes pentadiene. So I'll go pentadiene here. Pentadiene, and we've got a couple of single carbon atoms coming off of there. Those are methyl groups. Okay, so we've got 2 methyl groups coming off of there. And so let's see, that's going to be off of the 2 and the 4 carbon atom. So it becomes 2, 4, and it's 2 methyl groups, so it becomes dimethyl pentadiene. Oh, and I didn't show where those double bonds were, did I? Oh, I better do that. I better show where those double bonds are for this pentadiene here. So let me change this here. Go back. Go like this. I better show those double bonds are coming off of the first and the third carbon atoms here. So I'm going to go 1, 3 pentadiene. And then I still have those 2 methyl groups. So at 2, 4 dimethyl 1, 3 pentadiene. All right, that's tricky. Even I messed that one up. Good thing no one will ever see this, and it'll be on the internet for everybody to see for like ever. Okay. I think there's a message or a moral in there something. Like never put anything on the internet you don't want your grandma to see. I don't care if my grandma sees my organic chemistry. All right, now here's a ring structure. So with this ring structure, we've got 6 carbon atoms, 1, 2, 3, 4, 5, 6. So that becomes a hexene, all right, a hexene. And so because it's a ring, we're going to call it cyclohexene. So I'm just going to go cyclohexene down here. Cyclohexene. Cyclohexene. Okay, and there's only one of them, and we're just going to assume that it's off of the first carbon. So we don't have to put a 1 here, but where would that 1 be? Well, we could start here and go around, or we could start here and go around. And again, we want to have the lowest number with our substituents. And so I'm just going to start here and go 1, 2, 3, 4, 5, 6 like this. And we just assume it's coming off of the first carbon because there's only 1 double bond here. We want to just assume that double bond is coming off of the first carbon, so we don't have to put a 1 there. If you did, I would mark that wrong, but we don't have to. All right, and now our substituents here. Let's see here. We've got a methyl. And here we've got 2 carbon atoms. That'll be an ethyl. I can spell. Really, I can spell. You know, if you can't spell, you could always go into chemistry. Okay. There's an ethyl group, and then here this substituent is chloro. Chloro. Now, with all these substituents, we want to put them in alphabetical order. So we've got C, and we've got M, and we've got E. And so if I remember correctly, in my alphabet, the C comes before the E, which comes before the M. So we're going to start out with our chloros here. So we're going to go 5 chloro, 5 chloro. And then we're going to go, after C comes E, so this becomes 3 ethyl. 3 ethyl, and then finally 1 methyl. 1 methyl. Okay, so it'll be 3-chloro-3-ethyl-1-methyl-cyclohexene. Wow, pretty good.